So today I wrote revised consensus up here because since our first consensus model, we have certainly learned some new things. So can you go ahead and take a look at your initial consensus model? Is there anything that you feel like we have figured out since we started?
No, the air is inside the bath bomb.
Okay, so Jonas right away is telling us that the air is not inside the bath bomb. Do we agree on that?
Yes.
Okay, cool. What's something else that we have figured out from the start?
Baking soda.
Why are we talking like robots? Go ahead, Liam. What have we figured out from the start?
Citric acid. Yeah.
Our what?
Our the things in the bathroom.
That do what?
Make the gas.
Do you guys agree with Liam on that? Okay, so that's interesting because when I look at our initial consensus model, we said that it was baking soda particles with air trapped inside, and Liam is telling us that we actually have figured out that the bath bomb is a mixture and there's certain substances inside. Okay, so let's start with that, okay? So you're gonna notice here that I have kind of this complicated set of columns, but today we're gonna just start here with what we see as inputs before we mix, okay? So I just heard Liam say that the substances we started with were baking soda, citric acid. I think there's one more though. What else do we need?
Water.
And water. Okay, cool. So I'm gonna start here, and can you guys just remind me, baking soda and citric acid at room temperature are what? They're solids. Okay, cool, they're solids. And water at room temperature is a?
Water. Wait, liquid.
At room temperature, it's what state of matter?
Water.
Liquid.
What state of matter is it?
Liquid.
Okay, cool. Okay, so I know I add all of these three things together, and if I were to put them on a scale, right, I know that they would have a certain mass to this part here. What did we actually see with our eyes after we mixed the baking soda, the citric acid, and the water together?
Bubbles.
Okay, bubbles, and what's a better word than saying bubbles? It's a gas, okay? So there's a gas, and what else was in that container?
Bath bomb water.
Bath bomb water? Do you guys agree with that? So if we know right now that there's a liquid, there's some solids, we're not really sure whether it's baking soda or not, and we've got a gas, right? Do all these things, if they're made of particles, could we find the mass of them? No? Okay. So if I have the mass here, and I'm thinking about doing this in a system, because systems thinking is really important. You all with me? When we did this ourselves and we put bath bombs in the test tube, we said, hey, the mass before and our mass after, if I keep my system closed, should always be what?
Same.
Oh, the same. That if I have baking soda, citric acid, and water, I want us to think of this top circle as a zoom in of the bath bomb. So look at your bath bomb right now. There's a lot that we have grown with. So how could we now represent the bath bomb, knowing that Leighton said there's some important substances in the bath bomb that get the gas to be made? Kyla, what are your thoughts?
You could put baking soda and citric acid in there, since like before you put it, there's no water in it, because if you put it in, it like makes the gas.
What do you guys think about that idea? Can we put baking soda and citric acid in our bath bomb?
Yes.
Yeah. Okay, and what state of matter is a bath bomb?
Solid.
Good, Pere, it's a solid, right? So how do you guys think I should draw baking soda and citric acid particles here?
Together, or like the packed.
Can you guys all show me with your hands? How do you think I should draw those particles in a solid bath bomb? Oh, good. Okay, cool. Okay, great. Okay. What was the other important thing?
Water.
You said that with such confidence. Everybody say water.
Water.
And I need a new voice because we've been hearing from some of the same voices right now. And so can someone new share with us how we could represent water? Thanks, Emma.
It's more spaced out than solids, and but it's still like kind of.
Let's go to the middle. Because I know that I take these two substances and I add it to water. And can you guys remind me, what do these substances, what do baking soda and citric acid do when they enter water? Well, they eventually do, but what did we know is true when we mix one ingredient with water? They what, everybody?
They're soluble.
They're soluble, so that means they what? Okay, they dissolve. Okay, so here we go. I'm going to draw my water. And I know that they're dissolving. But this is weird. Because if they're just dissolving, then that means I don't get the bubbles, right? Because when each of these substances went with water by themselves, they just dissolved. But we now know that when there's both of these substances plus water, is there something else happening to make the gas?
Yeah, chemical reaction.
We're throwing at this idea, right? But do we actually know what that is? So I think that that's an idea we have to explore. So if I have my water with dissolving happening, potentially a reaction, whatever that means, right? I now come over here, and we're going to come over here to this side here. So can we consider here that leftover was our container? Can you guys remind me that when we put the bath bomb inside the container, what happened after we mixed them? What was there?
Air.
Okay,
Gas
there definitely were gas bubbles, but what else was there?
The water.
Bath bomb. Wait, yeah.
Let's first start. Can you guys remember when I had this here?
Yes.
And this was my line. What went up to that line?
Water.
Okay, are we in agreement that we think that there was water in this container?
Yeah.
There was a liquid, right? I know it's not here anymore, I'm sorry, but was there like a liquidy substance in here that we think was water? Okay, so that's my first start. Mrs. Biala, could you go ahead and draw some water up there in the container? Yep. Zoom in. But when we come in here, guys, do we think that the only thing in this container was water and the bath bomb gas?
Definitely.
Say it,
not.
Pam.
Look, it changed.
Yeah, it changed so much. And this is weird because if this is water, and I'm going to pass this around to you guys, I am going to ask that you not touch it, okay, just because I want it to stay intact. So are we going to touch it?
No.
No, but you can certainly smell it. But when I look at this, does this look like these things that we started with?
Yes.
Maybe? Could they be?
Yes.
Maybe could they be something different?
No.
Yeah. Maybe.
Okay, pass it around.
That's just not.
All right. So I'm going to put some question marks here because we're not really sure. I heard some people say that when we put these substances inside water, we get the gas. So can you go back to your yellow sheet for me? And I think from all of our testing, we narrowed it down to 3 possibilities. Is that right? So can you go on that yellow sheet and raise your hand when you find the 3 possible bath bomb gases? Juan de Dios, what was one?
Nitrogen?
Do you guys agree with Juan de Dios? Yes? Okay, what else could it be? Anya?
Argon?
Do you guys agree with her? Yes. Cool. And everybody, what was the last one? Okay, guys, I have argon, nitrogen, and carbon dioxide that the bath bomb gas could be. At room temperature, all those things are what state of matter?
Solid.
Gas.
Oh, gas.
Let's try again. Argon, nitrogen, and carbon dioxide at room temperature, they're all what state of matter?
Gas.
I just heard people say we made argon, carbon dioxide, or nitrogen. Can you all look up here? Do you see any of those particles up here with what we started before?
No.
No, they are new substances because they are a gas at room temperature. And baking soda and citric acid, we said yesterday, are solids at room temp, and water is a liquid at room temp. So do we have a new substance? Is our gas new? And if it's new, can we represent it the same way with a green or a pink or a blue particle? No, we can't.